Okay, once again, this whole chapter, we've been doing different things with functions. This is going to kind of look like yesterday, where they're going to give us multiple functions to start the problem, and we're going to do different things to it. Yesterday it was add, subtract, multiply, divide, some kind of operation. Today we're going to do what we call composition of functions, and we're going to take one function, put it into another function, and put them together, basically. And there's a couple of different ways that you'll see this written out. One way that you might have seen this written out before is like this. F of g of x is the way we would read this. But the way that we're going to see it more often today is like this, okay? And so it's going to have a little circle symbol. It kind of looks like fog, but that little circle symbol, sometimes people think it's multiplication, but it's not multiplication. If it's multiplication, like yesterday, we don't put the symbol in there. We just put FG for F times G. And so if I see that little circle in there, then that means the way that I would read this is F follows G. And so in either scenario, what we're doing is we're plugging the G function into the F function. We're working backwards, basically. And these two might be flip-flopped. And I didn't really talk about that a whole lot yesterday, but like when we do operations, order does matter, okay? Especially if it was like subtraction, where if I put, yesterday, if I did F minus G and G minus F, then it does matter which one we put first. And today, order is definitely going to matter, because we might see sometimes where it might do G follows F, and it might just be taking the two functions and flip it. But basically what's going to happen here is they're going to give us two functions, an F function and a G function are typically what they're going to name them, and then we're going to do the composition. Sometimes we'll find a value. There might be a value here like 3 or 7 or something like that, but sometimes we'll just do it with the actual functions themselves. Okay, so I'll show you a couple of different examples of some of these. But starting off, they're going to give us two functions. And once again, any of the functions that we've talked about all the way back from like the very first section, we could see linear functions, we could see quadratic, cubic, square root, absolute value. We got a list of a bunch of different things. And so that's why we kind of started off in section 1, where these are all the functions that we're going to see. Some of them we see more than others, like linear and quadratic are probably the two that we run into the most. Those are the ones that we use the most, but we could use any of those functions that we have talked about so far. The other thing that's going to be pretty similar to yesterday is we're going to do multiple parts here. So I'm going to write out 4 problems here. A, B, C, and D. Actually, and I'm going to add one more part here. Okay, and the reason why there's so many parts is that way we can just keep using the same two functions over and over. Okay, it wouldn't be a whole lot of fun to like, here's the two functions we're going to use for this one, and then it'll give you a new two functions. And so we're going to keep the same two functions throughout the problem, but we're just doing a bunch of different things with those two functions. Okay, so F follows G of X. What this means is we're going to take the G function and we're going to put it into the f function. So we're going to put this whole function here, g, and take it and put it in for x over here. So it replaces any place that there's an x. So when we write this one out, we would go 2, and then we're going to insert the g function. Like that. Okay, then we're going to simplify it. So in this case, we got to distribute the 2. And then to finish it up, we're going to combine like terms. And that would be our answer. So we're just going to, in that particular instance, we're just going to leave our answer as subfunction. Okay? We're not going to put anything into it or anything. We're just going to answer, kind of like we did yesterday. Sometimes we would insert a value. Sometimes we would just leave it as an expression. Okay, for part B, this one's a little bit different. Now we're going to go f into g. And the reason that this one's a little bit different is we're going to take 2x minus 5, and we're going to put it in wherever there's an x over here, but there's 2 places that we have an x over here. So the 2x minus 5 has to go in to both places that there's an x. So there's a little bit more work involved on this one. First thing I always like to do is just to rewrite it. So 2x minus 5 squared minus 3 times 2x minus 5 plus 8. Okay, and as we kind of talked about yesterday as well, there's just a lot of algebra skills and some things that we're going to have to kind of remember. And I think this one right here is probably the one that gets missed the most in a situation like this. Because when we see 2x minus 5 squared, probably the most common mistake is I'll see people take 2x and square it, and they'll take negative 5 and square it, and they just square both parts. But this is a binomial. And when I square something, that means I'm taking it times itself. And so what that really is going to look like, I'm just going to move it up here. We're taking 2x minus 5 times itself. Whenever we square something, we're multiplying it by itself. And so really what it is it's a FOIL problem. Okay, and we talked about FOIL yesterday. But writing that out is a really big deal, okay, because that way you get all the expression, get the whole thing. So we're going to FOIL this out. And then we're going to combine the middle terms together. So we're going to go 4x squared minus 20x plus 25. I'm just going to move that down here. Then we're going to take this negative 3 and we're going to distribute it. And then negative 3 times negative 5 would be positive 15 plus 8. Okay, and then to finish it, we're just going to combine like terms. 4x squared, nothing to combine with it. Negative 20x minus 6x would be negative 26x. And then finally, 25 plus 15 would be 40. 40 plus 8 would be 48. And that would be our answer. All right, for part C down here, there's kind of like we did yesterday, there's a couple of different ways that you could approach these problems, okay? And I don't necessarily care which way you go. I'll kind of talk about both. I probably won't work through all the work for both. One way you could do it is I could take 7, and we're basically working backwards. So I could take 7, put it into the g function, and then take whatever answer I get there, plug it into the f function, okay? And I'm just working my way backwards, and we're gonna actually evaluate it. So on something like this, because I have a number right here, my answer is gonna be a number. It's not gonna be an expression like the first two problems that we did. Okay, but the other way I could do this is because we've already done f follows g. We've already done this part right here. This is the answer for f follows g, right? That's the expression for f follows g. So all I really have to do is take 7 and plug it into this thing right here. Okay, I don't have to go through all that other work. So a couple different ways we could get there, but I think because we've already done the work on part A, that would probably be the route that I would go on this one. So we're going to go 2 times 7 squared minus 6 times 7 plus 11. So I'm just taking this function and putting 7 into it. And something like this you could probably just put right into your calculator. 7, you got to do order of operations though. If you plug it in just like that, especially make sure you use parentheses, and because you got to watch out for negatives and things like that. But exponents first would be 49 times 2 is 98. 98 minus 42 plus 11. If I do all of that, I think we end up with 67. So we get an answer of 67. Okay, G follows F. We already did it, right? We got the answer for it here. So as long as this is right, that could be an issue, because if I miss this and then I plug a number into it, then obviously I'm going to miss that. So that could be an issue. But because if you're pretty confident about this, now I could take 7 and I could plug it into this answer right here. And so this would be 4 times 7 squared minus 26 times 7 plus 48. What do we get on that? Anybody got their calculator out? You should be able to just type it in just as it is, all at once. You don't have to break it up into parts. Okay, so notice that we don't get the same answer here, right? And I mean, we could get the same answer, but typically you won't. And so what you got to remember is that F follows G and G follows F is not the same thing. Okay, these two answers obviously are different, so I'm not going to get the same thing. So that's why, as I talked about at the beginning of the lesson, order matters. The order that I do this in and the order that I go in is extremely important in how we do the math and how we do the algebra. Okay? So you got to be really, really careful as you go through it. Okay, for part D down here, G follows G of 1. Well, we haven't done G follows G yet. And this is a little bit different, but because we're plugging in a number, I do this one just to show you that you can use the same function twice. So on this one, we're not even using the F function at all. We're only going to use the G function. So I'm going to take 1, I'm going to plug it into G, I'm going to get that answer, and I'm going to plug it into G again. So I'm going to start with 1. 1 goes into G. So this would be 1 squared, which is 1, minus 3 times 1, which is 3. So 1 minus 3 is negative 2. Negative 2 plus 8 would be 6. Okay, so that's what I get when I plug 1 into G. I get 6. Then I'm going to take 6, and I'm going to plug it into G again. We're just working backwards. So basically, I'm going to evaluate twice. First time I'm going to plug in 1. Second time I'm going to plug in the answer that I got. So then I'm going to go 6 squared is 36, minus 3 times 6 is 18, so 36 minus 18 would be 18, and then 18 plus 8 would be 26. And so my answer here would be 26. And on this one, I would say, I mean, you could do a couple of different things. You could take G and plug it into itself, but that's going to be a little bit difficult, okay? It's going to be kind of hard to do. So the best way to do this one is just plug in the number, evaluate it, and just go through the math. Okay? And you can do it as 2 separate problems. Any questions on that one? Does that kind of make sense? Okay, but then on E, it's basically the same problem. We're only using F here, but we're not putting in a value. Okay, I'm not taking a number, putting it into F, putting it into F again. If I had a number there instead of X, then I would just take that number and I would put it in. Here, when I plug X into F, I just get 2x minus 5. So really what we're doing in this one is we are going to take F and plug it into itself. We're going to put F back into F. That's it. Okay? Well, F is 2x minus 5. So we're going to put 2x minus 5 in to 2x minus 5. So when I put 2x minus 5 in, I put it in where the x is. So I just put 2x minus 5 back into itself. And then I just got to do some simplifying. And we get 4x minus 15. Okay. So, and I know I've said it a lot, but if there's a number in this slot right here, your answer is going to be a number. Okay. If there's an x or a variable right here, then your answer is going to be an expression of some kind. Okay, and it could look quite a bit different. Sometimes it could be quadratic, it could be linear, it could be a lot of different types of things. Okay, questions on any of those? All right. I'm going to show you a couple of different variations, and on these, what we're going to do is I'm going to kind of show you some with some different functions. I'm going to show you some that I will tell you this, kind of like yesterday, they are taking out domains. And so some of the problems today, you're going to see them ask for the domain, but you don't have to do any domain work, like we kind of talked about yesterday. That's one thing that they're not asking us to do anymore. For whatever reason. I don't really know but that's good for you guys because that's one less thing to worry about. So don't ask questions, right? If they say don't do it, I'm not going to do it. Okay, so let's start with this one. We're going to do F follows G of X. And then we're going to do G follows F of X. So we're going to do it both ways, okay? And we'll kind of talk about this one because this doesn't happen very often. But if I take G and plug it into F, the 3's are going to knock out, which just leaves me X. If I take F and plug it into G and go the opposite direction and plug this one in over here, once again, 3 minus 3 is 0, and it leaves us X. So I told you on the previous problems that we may not always get the same answer. Typically we won't. But when I do F follows G and G follows F, it is a possibility to get the same answer, and that's what happens here. They both end up being X, which means that these two things are inverses of one another. They're basically doing the opposite operation, because when I subtract 3 and add 3, they cancel each other out, right? And so that's why both of these end up being back to X. So those two expressions are what we call inverses of one another. This time, we kind of did one like this earlier, but we're going to do F follows G of X, and then G follows F of X. So the first one, we're going to plug G into F. Okay, what do you think would be the first thing that we would have to do here? Foil it, yep. Because when I see this squared, I got to do 4x minus 3 times 4x minus 3. And however you want to do that, however you want to write it out. But writing it out, I think, is a big deal. Because when we see 4x minus 3 squared, we're really just taking 4x minus 3 times itself. Okay? Whether you do it to the side or you do it within the problem. So here then I'm going to distribute or FOIL. Combine like terms. That would be our answer. Okay, if we were to do the other way, F into G. We're going to simply take x squared minus 3, put it in for x over here. So this is just a simple distributive. And combine like terms. That would be our answer. Okay. So one was definitely a little bit easier than the other, but we definitely don't end up with the same answer. Quite a bit different. All right, the last example I'm going to show you here. I'm going to bring in a different function that we haven't seen yet today. And as I told you, you could see radicals, you could see absolute value, you could see any of the functions that we've done or worked with. So here we have a linear function, 2x plus 1. We have a square root function, the square root of x. And we're going to do the same thing. We're going to do f follows g of x. And we're going to do g follows f of x. Okay, so the first one, and it looks kind of like it's going to be hard, but this one's actually pretty easy. We're taking this function, which is just radical x, and we're going to put it into the f function where the x is, right? So the radical x replaces the x. There's nothing else that we can do. That is our answer. So it looks kind of weird. It's a little different because it has a radical in it, but that's all we can do. In the past, we used to do like the domain with this, like what x values would work, but we're not going to worry about that right now. That's not something that we're going to be doing. So that's one less step we have to worry about here. And then g follows f of x means we're going to take 2x plus 1, and we're going to put it in for x over here. And once again, it's not that big a deal because the 2x plus 1 just goes in for x. Goes underneath the radical. There's nothing we can do to simplify it. We don't have to try to take the square root of that or anything like that. If we knew if we had a number that we were plugging in, then I would take that number and I would plug it in here, but we're not even doing that here. So that's my answer. Okay, it looks a little bit different, but pretty straightforward. Okay, just putting it right into the function. That's it. That's compositions. And I'm going to give you a pretty short assignment today, too. 5 through 25, going by fives. So just 5, 10, 15, 20, 25. Some of them have multiple parts to them. So there's only 5 questions, but kind of like we did on some of the examples, then there's multiple parts to a couple of them. And once again, kind of like yesterday, don't worry about the domain. We're not worried about the domain of these questions. So really all you're going to do, like if we look at 5 and 10 are pretty straightforward. On number 15, it asks you to find all of them. So the first 3 parts, A, B, and C, are asking you to find the domain. You don't have to do the domains, so no domain questions. So really on numbers 15, 20, and 25, you're just going to do parts D, E, and F. Oh, you know what? I was looking at 2, 3 from yesterday. That's my fault. So, I was looking at the wrong page. So 5, 10, and 15 are pretty straightforward, and then 20 and 25. You're just going to do F follows G of X, and G follows F of X. It says to find the domain, but you don't need to find the domain. Okay, so just do both of those.